Hi, thank you for joining us for this session. My name is Ruti Arazi and I'm part of Lyve Labs Israel. Lyve Labs is Seagate's innovation center. As a global company, Lyve Labs Israel was launched with a purpose to become a collaborative platform where we can partner with the ecosystem to create solutions that harness the power of data. Data growth is exploding and expected to reach 175 zettabyte by 2025. With this data growth comes complexity in terms of moving, securing, storing, managing, and making usage of this data. Companies can no longer develop solutions to this challenge alone. At Lyve Labs, we want to collaborate with companies to increase storage opportunities, learn from partnerships, increase brand reputation, and customer breadth. The session today is a description of a successful proof of concept we held with a technological startup called Converge. Converge.io is a platform designed by data scientists to organize and simplify every stage of a data science project, including research, information collection, code writing, and model optimization. This POC aligns with our mission, and as you will hear, in just a matter of weeks, we could understand the benefit of their solution. You'll be hearing from Bruce King from Seagate and Leah Kolben from Converge. Bruce is a data science technologist in the advanced analytics groups at Seagate and has been with the company for over 20 years. Leah is the CTO and co-founder of Converge.io, which she co-founded in 2016. Bruce and Leah, take it away.
Thank you, Ruti. Part of the responsibility of Seagate's advanced analytics team is to identify new products and technologies in the machine learning and AI fields. We then design and manage proof-of-concept projects that can be followed up with factory-scale pilot projects and then ultimately enterprise-wide deployments. An example of one of those enterprise-wide deployments is the Seagate EdgeRx machine learning inference system. EdgeRx is deployed in all of our Seagate factories today, and we're ramping up the workload on that system. With this ramp-up of workload, we've come to appreciate the critical importance of machine learning operations, MLOps. Seagate Advanced Analytics and Converge are collaborating on a detailed proof of concept using their Converge MLOps enterprise platform. Here's a subset of the requirements we think we need to achieve full deployment of our ML technologies across all Seagate operations. At the highest level, we need to manage the version control of model training data, the actual training of the machine learning models, and finally the deployment and monitoring of those models in our production hardware. Being able to run on a hybrid cloud architecture is important to us so that we can effectively manage our expensive on-premises resources as well as scale to cloud resources. Our experience has also shown that early collaboration between data science teams across Seagate's operations helps make deployments easier and much smoother. It also supports the rapid sharing of machine learning best practices and standard approaches. We also need to be able to monitor in production model inference deployments and to trigger the retraining of machine learning models whenever needed. The data used to train and validate all of our production models also has to be version controlled. Moving and caching modeling data between the sources in the factories and the training compute resources, whether they're on-prem or in the cloud, would also really improve efficiency. Leah Kolben is the co-founder and CTO of Converge. She will now discuss with you how Converge's Enterprise MLOps product addresses these big challenges. After Leah's presentation, I'll briefly share some highlights of what we've learned so far in our proof of concept.
Thanks, Bruce, for the nice introduction. So like Bruce mentioned, Converge is an end-to-end solution for data science teams to manage all their data science projects in one place. Our end-to-end solution enables teams to easily operate in a hybrid cloud environment, scale machine learning resources quickly, and solve key MLOps challenges to get more models into production. The main goal of the POC was to show that Converge is a one-stop shop for all the data science needs and requirements within the enterprise. The first requirement was to be able to connect all different compute resources, cloud and on-premise, to leverage them with their data science project. We then wanted to allow each data scientist or data engineer in the team to use Converge to execute their different projects and leverage all the different components in Converge, from uploading and managing their datasets training models and publishing them into production, and automate their project by using Converge pipelines. I'll now explain each component and how it was used during the POC. The first requirement we had, like I said, is to be able to connect the different Kubernetes clusters to Converge, the AWS Kubernetes cluster and the on-premise Kubernetes cluster, so the data scientist teams are able to leverage all the resources. Data scientists first can use their on-premise compute resources, and once all the on-premise resources are 100% allocated, they can then burst into the cloud and run the training jobs on the AWS resource. The team also used this dashboard to monitor the allocation and utilization of the different resources and track the consumption by all the users, all the different projects. Every data science project starts with data. So data scientists can upload their data directly to Converge, so everything is managed in one place. Each data that you upload to Converge is tracked and managed, and you have different data commits, so you can run and train your workloads on different dataset commits of the same datasets. One thing that is important in data is that if you have a large-scale dataset, you wouldn't want to wait all the time that it takes for the data to be downloaded for each workload. So in Converge, we have the ability to cache your dataset directly to the workload. So every time you run a workload, instead of cloning the data from scratch, you would be able to attach that specific commit directly into the workloads. This could save a lot of time for the data science or data engineers using the datasets. Once the data is uploaded to Converge, the data scientists can now run their workloads on top of the data. They can first use Converge workspaces to be able to understand their data, debug, and run their code on top of it. They can use Jupyter, VS Code, or RStudio to do so. Once the code is ready, they can now run multiple experiments on top of the data. Each experiment can run on different type of compute. It can run on CPU baseload, or GPU, multi-GPU, distributed run like MPI, or PyTorch distributed. Once the experiment is executed, the data scientist gets a live dashboard that get updated as the experiment progresses and can track and visualize all the metrics of the experiment. At the end of the experiment, the data scientist can understand and see all the artifacts that were created during that specific experiment. The data scientist can compare between all the running experiments in the project and then decide which one of the experiments has the best results. Then they can take the artifact of that experiment and put it in production. In this POC, we had a really interesting use cases where we wanted to be able to publish an images to Kafka topic, and with Converge endpoints using Kafka, we will pre-process those images from the Kafka topic. We'll send them to a prediction using TensorFlow serving in a gRPC protocol, and then send it back to a Kafka output topic. In this use case, we needed to use two different types of endpoints in Converge. The first one was a Kafka streaming endpoint, which will listen to the Kafka input topics and will publish the results back to the Kafka output topics. And then the prediction itself will be able to do by using TensorFlow serving endpoints using the gRPC protocol. Every input and output is tracked in Converge, and you can follow the logs and the charts of the different endpoints and see how the endpoint behaves. Once you're ready, you can create a pipeline to automate your data science workflow inside the project. For example, you can create a flow that runs a pre-processed task on a specific compute. Then the processed data will transmit it to the on-premise compute and run the different workloads on top of the GPUs on-premise. Then we will compare automatically the different results of the workloads, and at the end deploy the best model to production. This makes sure that you always have the most updated and best model in production. Now I will return it back to Bruce, so he will be able to summarize the POC and the lesson learned during that POC.
As you can see from Leah's presentation, Converge is a powerful, feature-rich data science application. Our collaboration with Converge on this proof of concept has taught us a lot about what is possible with machine learning operations. Here are a few of the things that we've learned along with some of the potential benefits. Using a sophisticated machine learning operations system will enable us to scale out our machine learning projects and deployments throughout Seagate operations. Reasons for that include having a low impedance path from machine learning idea to machine learning deployment. Managing the workload through our on-premises GPU servers and our hybrid cloud resources allows us to optimize utilization of those expensive resources while also expanding the availability to more data scientists company-wide. Having an MLOps tool will improve data scientist efficiency, we estimate, by up to 30 to 50% compared to using a mix of unconnected open source tools to meet the requirements that I discussed earlier. Adopting a machine learning operations platform will enable our IT organization to focus resources on the MLOps platform instead of having to support a wide variety of open source and commercial tools as they proliferate throughout the company. And that concludes my presentation. Thank you for your attention.
Thank you, Bruce. Thanks, Leah. We hope you enjoyed this session, and please don't hesitate to reach us with any questions you may have, or if you think we should get to know each other. We're always looking for interesting new collaborations. You can reach us in the address here in the slide, or look for us for our LinkedIn page, Lyve Labs Israel. Thank you very much.